The author introduces abstraction at the beginning of chapter 1. Abstraction is a very important concept in the field of computer science, and we will be looking at it throughout the course. So what is abstraction? It is a mental model. The main point about abstraction is it removes complex details. There are two concepts about abstraction. One is removing the detail. By removing the detail, you allow yourself to focus on the item that you are doing right now. So let me give an example, a wedding. Wedding is very complex. However, if I remove all the detail, I'm trying to plan a wedding, and I focus on one property, let's say the cake, then I'm blocking out all the other details so that I can successfully get that cake ordered. The other concept is generalization. So when you remove the details, you may see with multiple items that, oh, with the details removed, there's a lot of similarities here. And when you see the similarities as a programmer, that allows you to write to the similarities and not to the details. So what's the advantage of writing your code to the similarities is you may only have to write it once instead of many times. To the left, we have here an abstract painting by Matisse, and you can still see, even though a lot of the detail has been removed, you can still see the concept that Matisse is covering. With this, the process of using abstraction means using something called stepwise refinement. We will be covering stepwise refinement later on when we get to algorithms. But by stepwise refinement, you take the big overall problem, which is pretty global, and you get to one little piece of it, just like I had mentioned with planning a wedding, removing all the unnecessary details. Here are some common examples. Braking your car. When you need to stop your car, are you thinking you're applying the brake pads? No. Turning on the lights. What is happening when you turn on your light switch? There's a lot of detail that's happening that you don't think about. And next slide we'll look at a steering wheel and how that works. And there are many examples of abstraction. So here's an example of driving your car. We steer our car using a steering, which is right here. I'm thinking I got to turn my car. I'll turn the wheel. But really, that's abstracting the fact that the steering wheel is turning, maybe if I have front wheel drive, these two wheels in that direction. Could you imagine if we did not have a steering wheel, which is what was going on right here? Could you imagine having to think, oh, I need to turn this wheel that way and this wheel also, and maybe I don't turn it correctly? Could you imagine having to think of how to turn each of the wheels in your car? Jeff Kramer wrote an article in the Communications of the ACM in a journal for computer scientists called Is Abstraction the Key to Computing? In it, he says, why is it that some software engineers and computer scientists are able to produce clear, elegant designs and programs while others cannot? And his conclusion was abstraction. I don't know if you've heard of Jean Piaget, but if you've taken some psychology, you may have studied him. He kind of wondered, what stages do children go through from birth into adulthood in their learning and what they are able to learn? And he separated those into 4 stages: sensory motor, pre-operational, concrete operational, and formal operational. Now you may notice the word think abstractly there is informal operational from 12 to adulthood. However, only 30 to 35% of adolescents get to this 4th stage. So in order for you to be a successful programmer, you will need to get to this formal operational stage. And if you're not there yet, you can learn it, but you need to be able to think abstractly. Okay, just more example, here is a map of Blackhawk College. We were closing some of the roads that go from building to building, and a lot of the detail is left out. Okay, so suppose you wanted to know where the networking lab is. You don't see it anywhere here. And the reason is, the purpose of this map is not to show you where the classrooms are at. The purpose of this map is specifically to show you which roads would be closed on which dates. So by removing the detail of where all the classrooms are at, it actually simplifies it. So here's an example of thinking about how there's commonalities once you've removed the details. So we've got some animals here. We've got a chicken and a doggy and a bunny. And we're going to give directions on how to feed the chicken. To feed the chicken, you put the chicken food in the chicken dish. Okay, here's the directions for the dog. To feed the dog, put the dog food in the dog dish. The rabbit, to feed the rabbit, put the rabbit food in the rabbit dish. To generalize, you might say, well, to feed any animal, okay, fill in the word. Dog. Put what? Any dog food in the dog dish. So we are able to generalize for all animals, let's say, how to feed them. Okay, here's a generalization. Have you ever noticed in a Windows program that they all have similar behavior? So have you ever noticed at the top, we've got this in the top corner of our window, and we know what each of those do? And that's a generalization. So regardless of what program, I know how to minimize that into the taskbar. You're going to learn something about functions. In fact, we'll cover a little bit about functions next week. Function is a concept in programming that says you can put in an input, a dog, okay, and there will be logic here, feed, that will output the dog. I can put an input, chicken, and get to the specific. I'm feeding the chicken. By using functions, you can generalize and not duplicate code. So that's the importance of the concept of generalization, which is also a concept of abstraction. You want to be able to see commonalities so that you don't duplicate the code. So where are you going to see abstraction? Well, we're going to start real soon with binary numbers. Abstract the machine level representations. Actually, in the end, there's not light switches, there's not zeros and ones. What is in the computer is electric signals. So just by representing electric signals as on and off, okay, as 0 and 1, we are abstracting that. We can then take those zeros and ones and abstract further. Zeros and ones can represent a movie? Sure, you've put a DVD into your DVD player and watched a movie. That is an abstraction of the electrical signals represented by zeros and ones. Waiting in line. So you've probably heard of a print queue. So that is an abstraction of waiting in line. I know you've entered a URL into a web page. There is a lot of detail that's happening when you enter that URL. We'll take a look at that in our assignment.